week 10, Thursday, and today we're going to do 3D Mohr circle. Okay, I've shown an example of 3D Mohr circle before, but now I'm going to write out I'm going to work through another example on 3D Mohr circle, and we're going to work on 3 different conditions where the 3D Mohr circle can be drawn based on these 3 conditions. Okay, so let's look at 3D Mohr circle. Mohr circle, the working principle is still using 2D. Okay, and 3D Mohr circle just means it has 3 circles rather than 1 circle in 2D Mohr circle. Okay, so we're going to look into a situation where we have now an element, or I draw my transformation first. This is your X, Y, and this is your Z. And we're going to construct a 3D element. Okay, so this is our 3D element. Okay, and just quickly, not quickly, I'll draw the associated stresses first. Over here you have 30 megapascal, and then you have a situation where you have 20 megapascal on compression. Okay, and then we have a shearing stress, and the shearing stress is positive 20 megapascal. The rest of the stress is equal to 0. So let's briefly recall that in terms of plane, we know that this surface over here is known as our XY plane. And this is our in plane, okay, because of largest surface area. And then this surface over here is known as our YZ plane. And we call this out of plane because the surface area is smaller. And then this surface over here is our XZ plane. And this is also known as our out of plane. Okay. So then we are going to label this, and so we call this our Z, our X. Oh, I should have used different color, pardon me. So this is our Z. This surface is our X on the Mohr circle, and this is Y. So now from here we're going to construct 3D Mohr circle. Okay. So we will have our axis. So this is our normal stress. Shearing stress, element rotate clockwise, element rotate anti-clockwise, 0, minus 10, 20, 30, minus 40, 10, 20, 30, 40, 10, 20, 30, 40, and then minus 10, minus 20, minus 30, minus 40. We are still going to use 2D Mohr circle principles, okay? So we know that we have one of our stresses is on our tensile 30. And then we have compression minus 20. So this, we know this is our stress X line. This is our stress Y line. Now Z over here, stress Z is equal to 0 because there's no associated forces or stresses. So this is our stress Z line. Then we have our shear 20. Okay, so this is our 20. Again, the shear is dependent on the rotation of the element. Okay. Okay, so let's look at the in plane, the XY plane. Okay, you have tensile 30 megapascal, and the 20 over here, which I'm highlighting in yellow, is going to generate a anti-clockwise rotation. So this is your point X. Okay, and on the other surface on Y, okay, on Y now, and this arrow is going to induce a clockwise. Okay, so this is your point Y. Then we can construct a line between point X and point Y. Then we know that we have a average stress of 5 megapascal, as you can see by observation. Okay. So this is usually, we label this our point O. Okay. And we can use very simple calculation, okay, to calculate our center of circle. Which is our stress average. So stress average is equal to stress X plus by stress Y divided by 2. So stress X is 30 plus by minus 20 divided by 2. That's where we get our minus 5 megapascal. Okay. And then from here, we can calculate the radius of our circle. And this corresponds to our tau max. So tau max, okay, is equal to, we can use very simple math, and I'll show you where we're going to get our values. So from here, from to here, this is equal to 10, 20, 25, right? And then, oh, before I do that, what are we trying to find is we are trying to identify this distance. We are trying to identify this distance from here to here. So this is the radius of your circle. It's also correspond to a tau max. And this value over here from here to here is 20. Oops. So very simple math. 25 squared plus by 20 squared. So this will be equal to 25 squared. 32.016. megapascal. Okay. And we also want to calculate our principal stress. What we try to identify here is also always our principal stress. So on 3D Mohr circle, principal stresses are always known as stress A and B. Okay, so these are your principal stresses. So it's equal to, sorry, this is positive 5, not negative 5, pardon me, plus 5 plus or minus 32.016. So one set of value will be at 37.016 megapascal. And the other set will be minus 27.016. Then we draw our Mohr circle. So 37, I'm just eyeballing this, okay? And then we have 32 should be somewhere around here. 32 somewhere around here. Okay. Now this circle over here, right? It is belonging to our XY plane. Okay. So this is our in plane. Then we also know that stress at point Z, okay, over here on the element is exactly at 0, 0 because it has 0 normal stress and 0 shear stress. Then we can construct another circle. Okay. 4, 5. And then we can construct another circle. And the circle will be here. I'm going to use red, a different circle now. And then this is just a sketch. Okay. So this is one of our circle over here. Now this circle that I've just drawn, wait, sorry, my bad. This circle that I've just sketched, okay, it belongs, okay, this circle that I sketched, it belongs to the YZ plane, which is our out of plane. Why YZ and not XZ is because point Y over here, right, to one of the principal stresses, this can be stress A or stress B, either one is fine. Okay, this angle over here is less than, right, less than 90 degrees, right? The angle is less than 90 degrees, or it's a mess now. Let me write elsewhere. So this angle over here is a cube angle, which is less than 90 degrees. Right, so point X to one of the principal stress is less than 90 degrees. We call it our YZ plane. Okay, so this circle is based on point Y and point Z. Okay, and then on the other side, okay, we are going to construct another circle. And I'm going to use pink. Okay. Now this circle now